Hi everyone, welcome to my channel. My name is Dr. Selena Vasquez Mireles. This video is part of the Pre-Algebra Stars Review series. Let's get started. Okay everybody, this is the middle school 6th through 8th grade Pre-Algebra Star Review. Remember that we're going to be doing the subject, terminology, assessment, and relevance. And this week we're doing the real number system. So that'll be our subject. So our subject is the real number system. Now you may see this in a few different ways. So let me show you which ways you might see them. Okay, one way you'll see it is, and you probably won't see this one until later, but in any event, I wanted to let you know what this looks like. You may see it as like a flow chart. So here are the real numbers. And then from there, you have the rational and the irrational. Then you have the integers, the whole numbers, and the natural numbers. Okay, and a good way to think about this is the real numbers in the real world. There are both rational people and irrational people, and so the same thing is true for the real number system. You have both rational numbers and irrational numbers. And then a subset of the rational numbers is the integers. A subset of the integers is the whole numbers. A subset of the whole numbers is the natural numbers. By the way, we also call these the counting numbers. Okay, now what do these numbers look like? We have to come in and fill that in. Let's do that really quick. So a good example of irrational numbers is, for example, the number pi or the square root of 2. These are non-terminating, non-repeating. Okay, they don't end and they don't continue in a way that repeats. The rational numbers do terminate and they do repeat. So these repeat or they terminate. Another way to think of the rational numbers is to think about this set. And you're probably not there yet, but I'm going to put it there because it's good to tell the truth, the whole truth of the information, and then you pick out what you need. Better to tell the whole story. Okay, so if you notice, the word rational has the word ratio in it, and what rational numbers are the ratio of two integers. So we write them sometimes like this. A over B, they're elements of the reals, such that A and B are elements of the integers. And I'm going to use these symbols. I'll come back and tell you what they mean in a minute. And we have to make sure that B is not 0. Okay? Now integers, so let's talk about that. So integers are the numbers that look like this, and I can try to put them in a set. I'm gonna try that. I'll do that first. So they look like this. They come in from infinity, and they're -2, -1, 0, 1, 2, 3, and they go off like that. So the integers, it's good to define them in terms of what they, the subsets. The whole numbers are the numbers 0, 1, 2, 3, and they go on forever and ever in that positive direction. And a good way to remember this is you have the number 0, and whole has the letter O, so can remind you that's the starting point. And the natural numbers or the counting numbers are what happens naturally. So we start with 1, 2, 3, 4, etc., etc. And it doesn't make sense for us to count numbers like 1/2, a third, a fourth. We count 1, 2, 3. It's how we do it naturally. So those are the counting numbers. So the counting numbers or the natural numbers are 1, 2, 3, 4, etc., etc. Then we add 0, that becomes the whole numbers. Then we add to the whole numbers, we add the opposites or the negatives of the natural numbers, and we get this set right here. And then we add all the numbers that can be written either as a repeating decimal or a terminating decimal, and those are the rational numbers, the ratio of two numbers. Now, I put something in there I want to show you really quick, and this is actually sort of part of the terminology, so I may circle back to that. But let me go ahead and show you why I use these symbols. So the real numbers is this funky R right here. Okay, this is like a double, I use a double line here. The rational is actually this weird Q. And why Q? Because Q stands for quotient. Okay, the quotient, this relationship right here. The irrational, we use the weird letter I. The integers, well, we already used I over here, so we actually used the Z for integers, and that's goes back a long ways. The whole numbers, we use the W, and the natural numbers or the counting numbers, we're not going to use C for counting because that's actually complex numbers, which is a bigger number system, but the natural numbers we'll use N. Okay, so that's another good way to write that down. Now you know why I put that weird Z there and that weird R there when I use this set builder notation. So that's the subject of real number systems. And I wanted to show you some of the other ways that you might see this when you're in class. So let me go ahead and show you that right now. You may see this as using a Venn diagram. So you may see this like this, or in circles, where you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, yeah, 1, maybe more. Sometimes you might see it like this. I'm going to show it to you like that. So you'll see these nested. Okay, and then I'm going to start from the inside out, and I'm going to use these symbols. I kept them here so you could see them. So you would use this symbol for the natural numbers, and then the whole numbers, and then the integers, and then the rational numbers, irrational numbers, I put them over here, and then the whole big thing is the real numbers. Okay, now another thing to just keep in mind is you can also see them on the real number line, and the real number line is just a picture of all the numbers, all the real numbers. Okay, and zeros over here. You can have 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. These arrows mean that they go on forever and ever. Okay, they go on forever and ever. They're infinite, and you'll see that these integers right here that I actually pointed out, but in between are the rational numbers, like 1/2, for example, is there. So you'll see some rational numbers, and you actually see the irrational numbers. They're all here, and we call this the real number line. Okay, so that's just another visual representation of the real number system, is the real number line. And just to clarify some things here, this is the positive side. This is the negative. So to the left, to the right, that's really important. This is going on to positive infinity. This is going on to negative infinity. So it's really important because the direction, and when we start combining numbers, we can use the number line as a model. All right, so that's the real number system, the subject. Now I just want to also tell you just a little bit more about the terminology. And I already did that, but I just want to recap. Okay, so there's the real numbers. Those are one of the sets: irrational, rational, integers, whole numbers. Just want to present it to you in a different way: natural or counting numbers. It's a nice organizational chart that you can do. So here you can, let's put the symbols. This is the reals, the irrational, the rational, the integers, the whole numbers, and the natural numbers. And you can also do some examples. So let's put some examples there. So real number is something like 7. 7 is a real number. The square root of 2 is a real number. Irrational, the number pi is an irrational number. Later you're going to learn about the number e. Okay, that might as well start hearing about it. Remember, we talked about telling the whole truth when it comes to numbers. The square root of 2 is also there. Rational numbers, 7. 7 is rational. 2/3 is rational. Integers, -5, 0. And let's put 7 again. Whole numbers, 0, 125. And natural counting numbers, 10. Let's put 7. Okay, so that's the terminology. That's what you use. Practice that, and that way you can be using the right terminology when you're in class, and it makes sense. It helps to understand things a little better. Okay, next is the assessment. So the assessment, this is an important, you're gonna have questions about the number system, but more than likely they're gonna be, as you continue in your math career, they're gonna be questions that have to do with words like, or concepts like domain. Okay, so they're gonna be embedded in some of the other things you're gonna be talking about. They'll be talking about the words range, domain, range. They'll be talking, it'll also come up when you talk about possible solutions or solution sets. So you might not be asked directly on a standardized exam except for your grade level, but you will be asked in through other ways as you continue your math career. So let me give you a quick example, and then I think we should be fine. So name all the subsets of the real number system that 1 is a part of. Okay, so let's just write them all down and see what we got. Okay, so let's put reals. I like to do this so that way I remember. Reals, and it's the rationals, the irrationals, the integers, the whole numbers, and the natural numbers. Okay, so let's see what we've got, and we'll just figure out whether it's one of those or not. I like to start from the set that's the most encompassing. So is 1 a natural number? Yes. Is it a whole number? Yes. Well, automatically it's going to go through these whole things because it's in this one, here, and then here. And that's my answer. All right. The last component for this is relevance. Okay, so where do we see the real number line in our real world? Some good examples are like a thermometer. Okay, a thermometer, we usually see them standing or vertically noted. There's a 0, there's positive, there's negative, like below 0 when it's really, really cold. Sometimes we see this in degrees, just common words. We see degrees Fahrenheit and Celsius. And you'll see that, or Fahrenheit. Okay, so we have a lot of times, some people would even say that you can see that in your clocks, that clocks have a form of a number line embedded, and they just cycle through though. That's when we tell time, it just continues, right? You can't go back, but there's some people claim that the clocks are another good example of number line. All right, well, there you have it for today. This is the idea of the real number system, and just to recap, I'll put this back up here for you really quick. Just a quick recap. Today's topic, or this first week's topic, was the real number system, and that was our subject. We talked about the different ways to talk about the number system, and how we would see it in test questions, and then how it's relevant to our real world. All right, thank you all very much. Good luck studying, work hard. Thank you.